In section 1 of chapter 6, we dealt with figuring out parts of a triangle that were not right triangles anymore, and we used the law of sines to do that. The one thing that you need to know or need to have in order to use the law of sines is you need to have an angle measure, and you need to have the length of a side that is opposite it in order for you to use that law of sines. Because then let's say that's 5 and that's 25 degrees. You can say 5 over sine of 25 degrees. Make yourself a ratio and then do that with all of the other parts to the triangle as well. So if that is side C or angle C, then you would have sine of angle C, side C, sine of angle B, and side B. And if you know one more of these parts, then you can just multiply diagonally, divide by one of them, and take the inverse sign, or just get the answer. And you can find all of the different parts of that triangle by using the law of sines. But again, you need to have an angle and a side opposite it. Well, now if we look at this example that is given here, we have an angle. We'll call this A, this B, and this C. And we know angle A is 50 degrees. Side B, which is opposite angle B, is 18. And side C, which is opposite angle C, is 25. Okay, the drawing isn't completely accurate, so let's change this. And maybe make it like so. So here we have an angle, but not the side opposite it, so we cannot use the law of sines. We would need to use the law of cosines. And the law of cosines says that you have a side squared equals the other side squared plus the other side squared minus 2 times BC times cosine of A. Don't get hung up on where the letters are located because these letters are interchangeable in that the B's and the C's and the A's can change spots. So it could be b squared equals a squared plus c squared minus 2ac cosine b, or it could also be c squared equals a squared plus b squared minus 2ab cosine c. Just know that this value squared, whatever variable it is, then that is what you put with the cosine of the angle. So if you have a here, then it's a there. If you have b here, then it's b there, and if you have c, and it's c. And then these two, the B's and the C's, are the other two sides of your triangle that you didn't use over on this side. And so, looking at this problem, we have these things. So if we wanted to find this side right here, which would be side A, it would be a squared equals 25 squared plus 18 squared minus 2 times 25 times 18 times cosine of 50. Then it's just a matter of using your calculator to figure out what that is equal to, and you would have a squared equals 370.49 approximately. Then taking the square root, then a would be 19.25. And that's how you use the law of cosines. Then moving on to this question, same thing. We have sides of a triangle at 7, 12, and 16. So we draw this 7, 12, 16 triangle. Now you pick a side, doesn't matter, or pick an angle, doesn't matter which one. So let's use this one here. And so we would say 16 squared equals 7 squared plus 12 squared minus 2 times 7 times 12 times cosine of the angle. And we will call it C. And so now you just have to perform your math with it. 16 squared is 256. 7 squared is 49, 12 squared is 144, minus, and 2 times 7 times 12 is a negative 168 cosine C. Now here's where people will make a common mistake is they'll take 49 and add 144 and subtract 168 and then move it to the other side. But you can't do that because of the multiplication symbol between the negative 168 and the cosine of C. You can only get rid of the 49 and the 144 by subtracting both of them. Then you will have a negative 168 cosine of C is equal to 63. And after that, you would divide by a negative 168 to get cosine of C is equal to a negative 63 over 168. And then finally, take the inverse cosine. Take the inverse cosine of whatever a negative 63 over 168 happens to be. And that will get you an angle, which is approximately 112 degrees. And so now that we know that that angle is 112 degrees, this one right here is 112, now we can go and apply our law of sines to say 16 over the sine of 112 is equal to 7 over the sine of B, which is also equal to 12 over the sine of A. And then you can figure and solve this by multiplying 7 times sine of 12, or sine of 112 divided by 16. And then take that whole thing, and that will equal angle B once you take the inverse sine of it. And so then you would get an angle, the other two angles would be 44 and 24. Because once you find the second angle, or once you find that second angle, doesn't matter which one you find second, then you know that you have 112 and 44, which leaves you with 24 left for the third triangle, or for third angle. Or you have 112 and 24, and then 44 is what's left for the third angle. And there you have used your law of sines to find all the different parts of the triangle. Finally, just like yesterday, you had to find some areas of triangles, and that formula is still 1/2 the base times the height. And then with the law of sines, or with sines, you would go 1/2 of the two bases times the sine of the angle that is between them. Well, if this is the case where you're given the three sides, neither one of these two formulas will work. And so there's another formula you should know, and it is this one here, where the area of a triangle, if you know all the sides, is S times S minus A times S minus B times S minus C. And S is equal to all of the sides added up and divided by 2. Similar to like almost finding the average, but it's not the average because you only have to divide by 2. So for this problem, the value of S is going to equal 10 plus 9 plus 8, which is 27. And so then to use this formula, and it would be 27 divided by 2, which is 13.5. So you would take and say that the area equals the square root of 13.5 times 13.5 minus 10 times 13.5 minus 9 times 13.5 minus 8. Going through all of that, that's 3.5, 4.5, 5.5, and 13.5. And still the square root of it all, multiplying that all out, and you should get 34.197 square units. And that would conclude everything that is part of Chapter 6, Section number 2, the law of cosines. So there would be the correct page that you were to be doing in Section 6.2 and the problems that you should do from that section.